As I said in an earlier lesson, energy is the capacity to do work. The energy a body possesses due to its motion is called kinetic energy. The motion of a windmill does work to grind grains. The motion of a fist does work moving the punching bag, and the swinging hammer does work to put the nail in the piece of wood. In the 17th century, an experiment revealed the relationship between velocity and kinetic energy. Two identical spheres were positioned at two different heights above a container of clay. The higher sphere was placed at a height where it would hit the clay at twice the velocity. The sphere with twice the velocity made a dent in the clay that was 4 times deeper than the lower sphere. This showed that there was a direct square relationship between kinetic energy and velocity. Kinetic energy is 1/2 mv squared, so as I said in the previous lesson, kinetic energy and velocity have a direct square relationship. If the velocity of an object is doubled, the kinetic energy will be quadrupled. If the velocity is tripled, the kinetic energy will be 9 times greater. The plot of kinetic energy and velocity, like all direct square relationships, has the following shape. Kinetic energy and mass have a direct relationship, so if you double the mass of a moving body, the kinetic energy will double. If the mass of the moving body was quadrupled, its kinetic energy would be quadrupled. All right, now let's use the kinetic energy equation. A 60-kilogram runner has 1,920 joules of kinetic energy. What is her speed? We substitute the kinetic energy and the mass into the kinetic energy equation. And you get a velocity of 8 meters per second. Since energy and work are connected, the amount of kinetic energy an object has is equal to the work needed to stop the object or to bring it from rest to a certain speed. Potential energy is equivalent to the work needed to get an object to where it is or to its present condition. For instance, a spring. Whatever work is needed to stretch a spring, that's how much potential energy the spring has. For instance, if it takes 40 joules to lift an object from the ground to a certain position, the object will gain 40 joules of potential energy. Let's go over what we've learned. Kinetic energy is the energy an object has due to its motion. The kinetic energy an object has depends on its mass and its velocity. Kinetic energy has a direct relationship with its mass, and a change in the velocity of an object has a very big effect on its kinetic energy. Velocity has a direct square relationship with kinetic energy. This is the end.